I am designing a custom suspension for my Cyberpunk car, and this time I cover more kinematic key performance indicators that I did not get to in my last video. If you haven't seen that yet, go watch that first. Link is up here. Later in the video, I introduce a course where you can learn how to design your own suspension, which I believe some of you will find rather interesting. In the last video, we covered all of these KPIs. Now, the other kinematic KPIs I will cover are wheel center offset, wheel center longitudinal offset, bump caster, and bump camber. Wheel center offset is the distance from the center of the tire to the kingpin axis as seen from the rear. When the wheel center offset is large, torque steer becomes more prominent. This is where the tire will turn when one wheel has more torque or grip than the other, typically when accelerating. This is bad and should be minimized. To minimize torque steer, the wheel center offset should also be minimized. However, this starts to interfere with scrub radius and kingpin angle, so these have to be considered when setting the value of each. Production cars can get below 40 millimeters with a double A-arm suspension, so I am aiming for this as well. Wheel center longitudinal offset is similar to wheel center offset, but looking from the side. This value should be minimized to reduce drive shaft plunge and angle for wheels that are steered. The solid gold lines are the drive shaft from the motor to the wheel. There are two pivot points in the drive shaft so that the power can be transferred to the wheels as the suspension moves. When the wheel is rotated, the middle link of the drive shaft actually changes length, and this is called drive shaft plunge. Drive shaft plunge is exaggerated here so it can more easily be seen. When the wheel center longitudinal offset is relatively large, the drive shaft must plunge more when the wheel is rotated. Ideally, the drive shaft stays the same length for all motions, so this should be minimized. I am aiming for less than 10 millimeters of offset. Bump caster is where the caster angle and caster trail changes as the suspension moves up and down. This KPI has a large impact on the feel of steering a vehicle. If the caster pole is positioned such that the caster angle and caster trail decrease as the wheel moves up, less torque is felt on the steering wheel. When the vehicle is cornering, more force is put on the outside wheel, and this wheel moves up relative to the vehicle body. If less torque is felt on the steering wheel when cornering, this can give false feedback to the driver, leading to unpredictable handling. The ideal behavior is to have the caster angle and caster trail stay the same or slightly increase as the wheel moves up. So have bump caster be between 20 and 0 degrees per meter. I will aim for the lower end of this range. Bump camber is where the tire gains negative camber as the body rolls. If a suspension has 0 bump camber and the body rolls by 5 degrees when cornering, the tire will have 5 degrees of positive camber, which is bad for grip. A tire has the most grip when it is perpendicular to the road, so adding bump camber will help the tire to keep grip, so more is generally preferred. However, if too much is added, it can be detrimental, as when accelerating or braking, the body pitches forward or back, and the grip of the tires can be significantly reduced. To have a balance of performance in accelerating and cornering, I am aiming for a range of 15 to 25 degrees per meter. This was all the KPIs I wanted to talk about in this video, but there are still many more that RACE provides. In the comments to my last video, many people were surprised by the complexity that suspension design actually has, with some wanting to learn more. Since this channel focuses on education and many of you want to learn more, RACE Software has been kind enough to offer a 30% discount on their suspension design courses, which is available only to those who watch this video. Now, for the sake of full disclosure, I will get a commission for each person who uses the discount code, which will go directly into financing this project. However, I ask that you do not use the code for my sake. My wish is that this code is used for the education of all those watching, if this is something you want to learn more about. The first course covers all of these KPIs and discusses them in more detail. The second course teaches you how to tune these KPIs hands-on, while giving you free access to their suspension simulation software so you can start designing a suspension of your own. After each course is completed, you are given a certificate which can be put on your resume. An advantage to using Race rather than just a CAD program to design the hardpoints is that it also takes into account the compliance of each hardpoint, which has a large impact on the performance of the suspension. If this is something you would like to invest in, use code PROJECT66HOON to get a discount. And again, please don't use it for my sake. If people want to donate, I can set up some other method when I actually have things to offer all of you in return. This discount will only be available until July 23rd. The link to their website and both courses, along with their YouTube channel, is in the description. Engineering is just educated guessing, and sometimes you get information that makes you update your guess. The team at Race was kind enough to look at my target KPIs and give some feedback, so I'm updating some of my guesses for my KPIs. First is bump steer. Instead of having between -1 to 0 degrees per meter of bump steer, it is actually more ideal to have closer to -5 degrees per meter of bump steer. This is because when it is in this range, it has some more understeer, which has more intuitive handling and stability at high speed. Now, there have been some comments about how I should give this car oversteer, since this car is a tribute to Ken Block, as it is easier to drift with oversteer. I completely understand these arguments, but there's two main reasons why I'm going with understeer. First, I am not experienced with racing vehicles, and since understeer helps keep the vehicle stable at high speed, I'm going to stick with understeer for safety. Second, I can always change the suspension later to give oversteer if I want to drift, though I think I might still have a way of drifting even with understeer. As for the other KPIs that I changed, they will be in the dynamics video which will be coming up. In one of my previous videos where I was describing the challenges of the project, I mentioned the car is rather large. Many people commented about adjusting the scale so that it is more like a normal vehicle. After doing some investigating, I agree. Though I cannot just scale the whole thing down, as when I do a fit check with my virtual double, my head is already through the ceiling. My virtual double's name is Dave, by the way. May Dave's dimension help us make informed engineering decisions. Anyway, I cannot scale the car down vertically, as I will already need to move the seat down. However, I can scale the length and width by about 10%, while still looking basically the same. I'm also going to modify the side fenders so that it's not as wide. This should give a much more reasonably sized car. And that's all I have for this video. Again, if you'd like to use Race software, you can use the discount code in the description on their website, which does support the channel. Also, I do read all the comments, even if I don't reply to all of them. I do sincerely appreciate everyone's support from the project. I thank you all. And with that, I thank you all for watching. I'll see you in the next one.